Have you ever wondered how our planet Earth came into existence? Our story begins around 4.5 billion years ago, in a time when the universe was just a toddler. The Earth's birth was not a solitary event, but rather part of a larger, grander spectacle, the birth of our solar system. All of this started with the nebula hypothesis, a theory that suggests that our solar system was once a nebula, a vast swirling cloud of gas and dust. This nebula was not stable though, it was teetering on the brink of change, and a nearby supernova was just the push it needed. The shockwave from this dying star sent our nebula spinning, and as it spun, it flattened into a disk. At the heart of this twirling disk was a bulgi, a concentration of Masth that was destined to become our sun. Meanwhile, on the outskirts of this disk, something magical was happening. The gas and dust particles were not just aimlessly floating around, they were colliding. Some of these collisions were destructive, but many were creative. They were sticking together, coalescing into larger and larger clumps. These clumps grew into planetesimals, and these planetesimals grew into protoplanets. One of these protoplanets was our Earth. It was a fiery, chaotic place, constantly bombarded by other celestial bodies, but over time it cooled and settled down. The heavy elements sank to the core, while the lighter elements floated to the top, creating the layers we're familiar with today: the crust, the mantle, and the core. But the Earth's formation was not just about physics, it was also about chemistry. As the Earth cooled, the elements began to interact. Oxygen combined with hydrogen to form water, carbon combined with oxygen to form carbon dioxide, and these simple chemical reactions set the stage for more complex ones, and thus our planet was born, setting the stage for the next big event, the beginning of chemistry. Welcome back to the Science Fiction channel. Please subscribe and hit the bell icon for notifications. Now, let's delve into mysteries of our planet. How did the simple matter that formed Earth evolve into the complex chemistry we see today? This question has intrigued scientists for centuries. During the early days of our planet, the atmosphere was significantly different from what we breathe today. It was filled with gases such as methane, ammonia, water vapor, and nitrogen. These gases served as the foundation stones of the birth of chemistry. Imagine a young Earth, still hot from its formation, with a turbulent atmosphere swirling with these gases. The heat of the planet, along with the intense radiation from the sun, provided the energy needed for these gases to interact. This set the stage for the first chemical reactions. Methane and ammonia, under these extreme conditions, started to react with each other. The heat and radiation disintegrated their molecular bonds, creating a soup of individual atoms. Now free, these atoms began to recombine in new and interesting ways, forming more complex molecules. Simultaneously, water vapor and nitrogen participated in this chemical dance. The water vapor, heated by Earth's warmth, ascended into the atmosphere. As it cooled, it descended back to the surface, bringing with it any atoms and molecules it met along the way. This evaporation and condensation cycle acted as a colossal natural laboratory, continually stirring and re-stirring the elements, making way for more intricate chemical reactions. Over time, these reactions grew increasingly complex, catalyzing each other in a succession of chemical events. The simple gases that once ruled the atmosphere transmuted through numerous interactions into a diverse chemical terrain This was how chemistry was born, the process that turned simple gases into the complex molecules that eventually laid the foundation of. So when you look around at the world next time, remember that every molecule, every substance, every piece of matter you see stands as a tribute to the might of chemistry. These initial chemical reactions paved the way for the intricate biochemical reactions that sustain life. Water, a simple molecules, played a critical role in the development of early chemistry. But how, you might ask? Well, let's dive into it. Imagine water as a grand stage where the actors are different molecules. These actors come together, interact, and sometimes even form new and more complex characters. In scientific terms, water acts as a solvent, creating an environment where molecules can meet, interact, and react with each other. One of the reasons water is such an effective solvent is due to its polar nature. Each water molecule, composed of 2 hydrogen atoms and 1 oxygen atom, carries a slight electrical charge. This charge allows it to attract and hold on to other charged particles or ions. Now, why is this important for early chemistry? Well, the Earth was teeming with ions in its early days. When these ions found themselves in water, they were able to move around freely, bump into each other, and in some cases react to form more complex molecules. This is where the magic happens. The formation of these complex molecules is the very basis of chemistry. Without a solvent like water, these reactions would have been much less likely to occur, if at all. Furthermore, water's unique properties, such as its ability to dissolve a wide range of substances, its high heat capacity, and its liquid state at Earth's surface temperatures, make it an ideal medium for chemical reactions. It's like water was tailor-made for the job. So, while we often take water for granted, it's essential to remember that it's much more than just thirst quencher. It's a master facilitator, a powerful medium that has shaped the course of chemical evolution on our planet. Without water, the chemical evolution of Earth would have been drastically different. The role it has played in shaping life as we know it is truly profound. So the next time you take a sip of water, remember the remarkable journey it has been on and the pivotal role it continues to play in the grander drama of life. From simple chemical reactions to life, how did that transition happen? It's a question that has puzzled scientists for centuries, and the answer lies in a theory known as abiogenesis, which suggests that life arose from non-living matter. To understand this, we must first grasp the basic building blocks of life: proteins and nucleic acids. These complex molecules, which make up everything from our muscles to our DNA, are thought to have formed from simpler organic molecules. But how did these simple molecules come together to form life as we know it? Imagine a world billions of years ago where the Earth's oceans were a primordial soup of these simple organic molecules. Over time, through countless chemical reactions, these molecules began to form chains. These chains, in turn, became the proteins and nucleic acids that are the foundation of life. The formation of these complex molecules was not a random process. Rather, it's believed that the conditions on early Earth provided the perfect environment for these reactions to occur. The presence of water, for instance, played a crucial role. Water acts as a solvent, allowing molecules to move around and interact with each other. This interaction, over billions of years, eventually led to the formation of the first living cells. But the story doesn't end there. These early cells were basic and primitive, far from the complex organisms we see today. However, through evolution, these cells became more complex, eventually leading to the diverse array of life we see on Earth today. So from a super simple organic molecules, life emerged. It's a fascinating journey, one that highlights the incredible power of chemistry and the remarkable resilience of life. The complex chemistry of life, it seems, had humble beginnings. And that's the beauty of it all. From the most basic of molecules to the intricate web of life, the story of life's emergence is a testament to the endless possibilities of the universe. So we've journeyed from the formation of Earth to the beginning of life. But what are the key points to remember? Our journey began with the formation of Earth, the third rock from the sun, a place we all call home. The Earth, in its infancy, was a fiery, volatile sphere, barren and inhospitable. It was a world in the process of creation, a cosmic cauldron bubbling with potential. But amidst this chaos, the seeds of a new discipline were sown, the birth of chemistry. As the Earth cooled, various elements began to interact, forming the first chemical compounds. These interactions, these chemical reactions, were the first steps towards a more complex world. This was the dawn of chemistry, the science that would define our world and everything in it. A crucial player in this story is water. That humble compound, 2 hydrogen atoms and 1 oxygen, was the stage where much of early chemistry took place. Water, with its unique properties, facilitated the formation of more complex compounds, laying the groundwork for life as we know it. It was the cradle of chemistry, nurturing the first reactions that would lead to life. And from this primordial soup, life emerged. The first life forms were simple, single-celled organisms, but over eons, through a process of evolution driven by chemical reactions, these simple organisms grew in complexity. They became multicellular. They developed different functions. They diversified into the myriad forms of life we see today. All of this was made possible by the power of chemistry. So, as we look back on this journey, let's remember the key points. The formation of Earth, a fiery sphere that cooled to create the perfect conditions for chemistry. The birth of chemistry itself, as elements interacted and formed compounds. The crucial role of water, the stage on which this chemistry played out. And finally, the emergence of life, a testament to the power of chemical reactions. The story of Earth and the beginnings of chemistry is a testament to the power of simple elements and reactions, evolving over time into the complexity we see today.